How does amplification enhance the signals, and why is this step necessary before sending the signals to the picture tube? Does amplification increase the strength of the signals, making them clearer and more useful for creating an accurate image? What happens when the electron beam hits a point on the sample, and how is this related to the appearance of a bright spot on the fluorescent screen? Could it be that when the electron beam strikes a specific point, it causes a corresponding bright spot to appear on the cathode ray tube, CRT, making it visible to the operator? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? How does scanning occur point by point, and why is this method of scanning important for generating the final image? Could it be that scanning in this manner allows for the collection of detailed information from each point on the surface, ultimately constructing the entire image of the sample? How is the overall morphology of the sample determined by the scanning process, and what is the significance of the point-by-point approach? Does this technique ensure that a comprehensive image is built up, showing all of the sample's surface features in high detail? How does the scanning of each point contribute to the final outcome, and could the overall morphology of the sample be understood by observing the full array of these individual points? Why is the cathode ray tube, CRT, so important for displaying the SEM image, and how does it work together with the electron beam and signals to form a visual representation of the sample? Does the CRT act as the final stage in which all the collected data is displayed as a readable image for analysis? What happens to the image generated on the CRT screen, and why is it so crucial for researchers to examine the surface morphology through this process? Does the resulting image provide key insights into the structural and compositional properties of the sample being studied? How can SEM, scanning electron microscopy, be used in conjunction with other instruments to enhance its functionality? Could it be that SEM, by combining with complementary tools, allows for a broader range of analyses and applications? What specific role does the energy dispersive spectrometer, EDS, play in this combination, and how does it help analyze the composition of microregions within materials? Could it be that EDS identifies elemental composition at different scales, providing valuable insights into the material's structure and properties? How does point analysis work in EDS, and what does it involve? Could point analysis mean that the electron beam is fixed in a particular range on the sample's surface for both qualitative and quantitative analysis of that specific point, enabling precise identification of elements at a single location?